And then at the end, what they do, again, this is not the instruction for it, is not done through the course, it's done through our design one and all of the others, but that's basically, this is basically student work that I'm demonstrating for you here. And this is a case of their testing. I have some data, assessment data, in terms of surveys that we've had relating to that. Obviously, everybody's satisfied with it, and they would recommend it to their students. And here are some comments for the class. Whether they got, I mean, our intention obviously is to expose them during their first year in, through the product engineering process, and to also have them put in perspective what is it that they are going to be learning in the engineering sciences classes that are coming up, and why they should be taking calculus and physics and so on and so forth. Another example is a robotics, an underwater robotics project that we have for them, again, as an engineering experience. In this one, what we basically do is tell them that they should build a remotely operated underwater vehicle with a grabber, and they're on their own to do that. Obviously, we're giving them Legos so that they can do that, and also the kinds of controllers that we can get through the Lego systems. The issue is not to use Legos to do something, the issue is to use Legos to build their prototypes, right? So the design is what is really of interest here. The objectives are to engage the students with a challenging project, incorporate discovery-based learning, and to expose them to an iterative design process. So that's what it is. Now, this one incorporates 10-minute talks, 5 short 10-minute talks into these 4 meetings, 4 afternoons again, where they have to do that. They're not given explicit instructions. They must invent things. And as I said, this is discovery-based learning. This is just a short 10-minute, part of a short 10-minute talk in terms of what can you do, how you can use gears to get the propeller going, and how you cannot just simply use gears to increase the speed, right? That it would have an effect on the torque that you're getting out of it, right? So that's, again, helping them move along in the process. So now, the way that we run that part is, if you look at item number 1, first they do linear motion with a single motor, then they go on and do a steering exercise with 2, then they go through a vertical motion, which they incorporate also buoyancy, then they go on to basically design the grabber or the gripper, and then the electrical control system, and then finally their design. I can give you some. Obviously, we have a lot of feedback on this end, so this is some of their work. It always works very well when you're not rushing. It's supposed to be. Come on. There you go. And so the testing part is when they do it in a portable swimming pool in our fluids lab. Again, some feedback in terms of whether they like the experience or not, and what students are telling us with reference to that. They talk about how they've learned to come up with things through discovery, whether it has been helpful in helping them focus with their studies, and so on and so forth.
How many credit hours?
This is on 1 credit. And as I said, this is not a continuous kind of activity. This counts for 4, oh, you mean this activity counts for 4 credits towards, not credits, 4 points towards the engineering experiences course, which is 1 credit. And it requires 9 points altogether. So if you think about the two that I just mentioned, 2 and 2 is 4 if they choose to do, I mean, 4, the two that I just mentioned, the two examples, 4 and 4 is 8, and there's one more that they could go from somewhere else in addition to the required activities that they need to go through.
How many years have you been offering it?
This is in its second year. Yes. The pilot was the pump 3 years ago. And then finally, it's the engineering design, which we haven't changed. This is the way it used to be, and I'm going to be very brief on this. This is the focus on this was to tie it to our computer engineering class, or to our C++ and computer programming. I lost my words. To our computer programming class, which basically focuses on algorithm building as well as C++. So it is a 2-credit course, and there are certain design-related activities that we cover in this class, together with a project which is supposed to build on people's experience or exposure in our programming class on algorithms and computer programming. The goals for the course is to improve the understanding of the engineering design process, to increase self-esteem and confidence in technical endeavors, introduce project management tools and techniques, and develop effective team working skills, in addition to creating friendly, competitive atmosphere which would foster innovation and success-oriented thinking. Again, as I said, the project part of this is what is the framework within which they have to apply what they've learned in their programming course. And that basically is done through a competition which involves strategy. And the competition basically is the following, that they have to, well, first of all, the task is that they have to build an autonomous vehicle which is going to knock out targets in the opposing team's court. The targets are lights that need to be turned off, and there is another, and they also have to have a navigation system that would allow them to get to the other side of the court and to also avoid obstacles along the way. The two courts are, one is painted black and the other is painted white, and they don't know which side of the court they're going to be in, so they have to also figure out their strategy in developing their algorithms would be to figure out where they are, right? So again, there's a great deal of interest and a great deal of enthusiasm when it comes to that. These are different renderings of the different types of vehicles that they come up with. Again, as you will notice, we use Legos quite a bit in terms of creating our prototypes. And then we have microprocessors that we have developed especially in-house, especially for them, so they can just simply program them as opposed to, having to, and the instructions are there and they're quite robust. And as I was mentioning, this last shot basically deals with shows you an actual competition, the white and the black, and the obstacles that you see in there. The light at the very top, which is basically that's the navigation, the equivalent of a GPS system, where they have to look and see where the light is and move accordingly. So that's what I wanted to report in terms of what we're doing. Sorry for being brief. I certainly could spend more time on it. That's what we have done in terms of the experience. It is very demanding in terms of time. It is resource demanding for sure. But I think that, at least I can tell you for mechanical engineering, it has paid off quite well. We have quite a lot of people who are moving out of other choices they've made and are joining mechanical engineering for this. I'm not suggesting that this would be the same solution for you. I think you could come up with your own course to fit your own needs. but just some food for thought. Thank you very much.